range, she says -4, focus this, to infinity. So range is the only time, really, we look at the y's. The lowest y value we reach is -4 to infinity, correct? How about parentheses versus brackets? What do you use? It's a bracket for -4, correct? Because -4 is actually reached. It's a solid circle. So we do include -4, and infinities, again, always have parentheses. How about your positive interval, Aiden? 1 to 3. So from 1 to 3 here, it's positive. Raise your hand if you had something different. Raise your hand if you also had 1 to 3. Okay. Raise your hand if you left it blank. Okay. Let's try this again. Raise your hand if you also had 1 to 3 like Aiden did. Nobody. Raise your hand if you had something different. That should be the rest of you. Very good. Okay. Micah, what do you have? From -1, say it again? Oh, 1 to infinity. So from here to infinity, it's positive. I think, raise your hand if you had something different than that. Madeline. -1 to -infinity? Okay. That would be good, except for you always have to go smallest to biggest. So what you really mean is -infinity to -1. I think we need to review what positive means versus increasing. Because, Micah, I think you gave me the increasing interval where it's going up, 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 right? That's increasing. Positive means above the x-axis. So Madeline has part of it. This interval here from -infinity up until -1 is -1. Is that point actually above the x-axis as well? No, so we do not include that. We use parentheses. What are you going to tell me, Nate? Yeah? Very good, because again, it's above the x-axis from 3 to infinity. And again, 3 itself is not above the x-axis, so we used parentheses, and he puts a union sign in between. Make changes to this as necessary, obviously. You don't want to leave the wrong answer on your paper. Negative, therefore, means below the x-axis. So what do you think for that, Jake? -1 to 3. Very good. This interval in here. So what did you use as far as parentheses, brackets? Both parentheses. Good, because neither of those endpoints are actually below. How about a relative minimum point, Connor? 1 -4 is correct. How about a relative maximum point, Evan? So if you can't list a point when they're asking for a point, it does not exist. There is no relative max. Okay? How about an absolute minimum point? John. When you, yeah, -3, and then you were looking at the graph, and to get the absolute minimum point, which would be right here, well, it's asking, -4 would be the absolute minimum value, but they did ask for the absolute minimum point, so give both coordinates as all. Look again. 1 -4, good. So I kind of pulled the critical points off the calculator first so we didn't have to keep tracing over and over and over again. Because once you trace one and you see what the coordinates are, maybe you get to it later, you forgot what those coordinates were. So rather than doing it multiple times, I just got that on the paper. Absolute maximum point, again, there is no absolute maximum point that this reaches. Mason, take your hat off, please. So that is also does not exist. x-intercepts, -1 and 3. Now I'm putting these in curly brackets because I'm listing them. Okay? I don't want to put parentheses or brackets or anything because I don't want it to seem like that's an interval. X-intercepts, you don't list them in interval notation. Okay? You list them out. And the y-intercept, same thing. I'm just going to list it. There's only one. It's at -3. Any questions there? Okay? This third example here, I'm going to circle it, is also something that we only have the function value for. But this one is a little bit different because we are limiting the domain that we're looking at. Okay? One thing I want you to change, just so we get exposed to something else, is I want you to make this strictly less than versus less than or equal to. Okay? So I'm going to again type this into my calculator. I want you to do the same. You may. Okay, but we're going to limit our window accordingly. So they're telling us to limit our x's from -5 to 5. So what I'm going to do is hit the window button and make my x minimum -5 and my x maximum 5. I'll adjust my y minimum and my y maximum if I need to. Let's see, I'm going to hit graph. Do I need to adjust my y window? Yes, because I'm missing a good chunk of the graph down here. So, and I'm actually missing what's going on up here as well. So I'm going to open up my y window and I'm going to go much further down to, let's go -50 to 50. That might be way too much, but I think it should be good. Beautiful. Okay? Yeah, so I do have everything throughout the whole thing. So this is what I'm going to sketch on my paper. So down below here, kind of looks like this. Now I'm not going to put arrows on the end of this one because it really wanted my graph to stop. It gave me that limited domain. And here's the, I guess the key to the inequality change that I made. It wants it less than or equal to on the -5 end. So I'm going to put a solid dot at the end point there. But it wants it only less than 5, not less than or equal to 5. So I'm going to put an open circle at the end point there. So that point is not included. This point is. Okay? And then I'm going to start labeling them. So how do I find out the coordinates here? I know it's -5 something. -5 what? Do you remember what on the trace menu I could do to figure out what pairs with an x value of -5? Nope, zeros are going to give me x-intercepts. Value. And I can type in -5, enter, it tells me it's -5, 16. Good. The next critical point is this x-intercept. So on my second trace menu, how am I going to find this x-intercept? Which option? 0. So this is going to now prompt us to do a left-bound, right-bound. So I have to bring my cursor to the left of that 0, which right now mine's barely blinking on the screen. There we go. I'm to the left of it, which happens to be above it here. Enter. Now on the bottom it's going to ask me to scroll to the right of my 0. So get below it, slightly to the right here. Enter. Bless you. It's going to say guess, hit enter, and I get -40. Now I do realize that on this particular graph you could kind of count that out, but there are a lot of graphs that you're not going to be able to do that, so I want you practicing this skill. Okay? Is the next critical point maybe my minimum? Yes, do we think? So second trace, look for minimum. Again, it's going to prompt me left bound, right bound. Bring your cursor to the left of the minimum, which I can't tell exactly where my minimum is, but I do know that that's to the left of it. Hit enter. Scroll over. Get to the right of the minimum. Hit enter. And then guess. You can ignore that. Hit enter through that. And here's my minimum. -0.5, -24.5. So -1/2, -24.5. Next critical point is our y-intercept. How am I going to get that? The y-intercept is when x equals 0. So for value, plug in an x of 0, and you get a y-intercept of -24. So that's 0, -24. Next critical point is my next x-intercept. Second trace. Look for your 0. Get your cursor to the left of that 0. Approximately there looks good. Hit enter. To the right of that 0. Hit enter. Guess. Hit enter. And 30. And finally, this at 5 comma something is where my graph is ending. 5 comma what? So second trace, value, x equals 5. The y coordinate that goes with it is 36. Okay. Like I said, I would get all that on paper first and then hit up filling in. So let's just go around increasing, and you're going to be on the spot here. But from where to where do you think this is increasing, Grace? I can't hear you at all, sweetie. From here to 5. It is increasing there. I'm not going to deny that, but it's also increasing elsewhere that you left out. Jake? So from this point to this point. Give me 1 second. What did he just do wrong there? He said from -24.5 to 5. Fix that, Isaiah? So from here to here, it's increasing the whole time? Yes. He accidentally pulled the y coordinate. Remember when we're doing intervals, we're always, and that's so common, we just have to get used to not making that mistake. From an x coordinate of -0.5, which is the vertex, the minimum, and it's increasing all the way to 5. So -0.5 to 5. Parentheses, brackets, what do you think? I tried to make this easy for you yesterday. All things increasing, decreasing, and constant are always parentheses. You don't even have to think about it. If you want to think about it, it logically makes sense. Is this graph?
Yes.
Okay. Calculator, just if something happens to you, how to fix it. So this is what he's looking at, and it's not showing kind of the same thing that I have. I think your window is just off. It looks like, if you look at your window, your x's are going from -10 to 10. Based on this, we said -5 to 5. And then you chose -22 to -2. Oh, so you always have to go in and change it. So usually I start by hitting zoom and then 6, which brings you to -10 to 10, -10 to 10. And then from there, we try to figure it out. Okay? So from there, we went -5 to 5 because it told us to. And then we were looking at this. It wasn't enough, so we went down further. So this is where we went -50 to 50. Although that still doesn't look the same as mine, right? So I'm wondering if you typed it in somewhat wrong. You did. You forgot the 2 out in front. So you can insert. Is everyone okay with, rather than delete the whole thing, you've got this insert above the delete button. you can hit second delete, and it allows you to insert something without having to erase everything. X minus 3x plus 4. Now we're golden. Okay? Good. Decreasing. What do we think for decreasing? Lydia? Not to 0, because it starts to increase right here. It's just -5 up until the vertex, which was at -0.5. -5 to -0.5. How about constant? What do you think, Mason? From -1, which is about here, to 0. I see what you're getting at. -0.5. So from the vertex to the next point. The vertex actually was a turnaround point, right? It's not. It's hard to see. It kind of looks like it's staying constant, but it is. If you know the shape of a parabola, it has turned around. It's actually increasing there still. We included -0.5 all the way here as increasing. You'll know constant. I'll make it an obvious flat line. It'll be obvious. So this does not exist here. Okay? Domain, what do you think? Oh boy, who haven't I called on yet? Cameron. For the domain? Domain is all the x values. No, this whole graph's x values range anywhere from -5 to 5. It's all the x values left to right, the lowest x value to the highest x value. Okay? What's that? Okay. So, and here is where we're going to start going. This one will be a bracket because it's a filled circle. This one will be a parenthesis because it's open. -5 bracket to 5 parenthesis. Okay? Our range, the lowest y value to the highest y value. What do you think for that, Jordan? Someone fix that up for him. Maggie, what do you think? Yeah, you just pulled the x coordinate. The range is really the one time we focus on the y coordinate to y coordinate. The lowest y coordinate is -24.5. Is that point included? Should we use a parenthesis or a bracket on there? Is that point actually reached? Yes. Okay, it's a solid point down there. Up until 36, is that point actually reached? No, because it's an open circle. So that would be 36 with a parenthesis. All right. Zach, can you take a stab at the positive interval? So from here to here, this right here, again, I think you're getting it confused with increasing. Positive means above the x-axis, and this entire section is not above the x-axis. -5 to what? Very good. So this section is above the x-axis. So -5 to 4. Are we going to use parentheses or brackets on the -5? Is this point actually above the x-axis and is it included? Yes and yes. So bracket. Up until the, -4. Up until this point, is this point included and also above the x-axis? No, it's not above the x-axis, so that's a parenthesis. Where else is this graph positive? We've got a union here because it's positive again. Go ahead, Bo. From 3 to 5, correct. Parentheses, brackets, what do you got? Both parentheses for different reasons. But yes, he's right. This one is a parenthesis because it's not actually above the x-axis. This one's a parenthesis because the point is not actually included. We follow? Is this getting easier? I hope. It takes a while to work out kinks, which is why we're spending another day. And the negative interval, what do you think? Is it Kirsten or Kirsten? So even though there's no I in it, you still pronounce it Kirsten. Okay, I just want to make sure I got that. Because I just realized yesterday that I might have been saying it wrong, but I'm not. Okay, Kirsten, what do you think? -4 to 3, parentheses, brackets, what do you think? Both parentheses, excellent. Relative minimum point. Grace, what do you think? Well, which one's lower, the -24 or the -24.5? Right. I realize that the y-intercept and the minimum are very close to each other, but the lower point is actually this one. So since it's asking for the point, we're going to give the coordinate pair, not to be confused with interval notation there. That's also the absolute minimum point. So we're going to say that again. Now, what do we think about relative maximum point? What do you think, Evan? Not relative. Okay, relative has to be a turnaround point. It has to be a maximum relative to what's on its left and on its right. Since this doesn't have anything on its right, you can't say it's higher than those relatively. So this one actually does not exist. You don't have any like maximum vertex. Okay? Now, absolute maximum, this is a teaching point here. This is something that we haven't gotten to. There is no absolute maximum. If this was a closed circle, it would be our absolute maximum point. Okay? But the absolute maximum point this gets to is actually somewhere around 4.9999999 and 35.9999999. Something like that, but we can't quantify that because truthfully, the absolute maximum this reaches is getting infinitely close to 36, like 35.9 repeating, but without actually being a solid value that we could quantify. So with an open circle there, we actually would say that this does not exist either, which is interesting. Okay? Because you're getting infinitely close to 36, but without actually reaching 36. So if someone said, well, 35.9 then the next person could say, no, 35.99 is actually closer to 36, and then we could play that game forever, because you can always add more 9s. Okay? X-intercepts here, -4 and 3, we're going to kind of list them, so we use curly brackets. Interval notation doesn't apply there. And the y-intercept is just -24. Any questions there? Okay. Let's go to this next one. And first of all, let me clarify what these say. We have -5, -145. I'm just going to rewrite that because it's not clear. What do we think this x-intercept is? -3.5, comma 0. This one says -244. This x-intercept is 0, 0. This point is 3, -81. I apologize, it didn't copy right. And this last one is going to be 5, 0. Okay? I want you to take a couple minutes to fill this in to the best of your ability. They are both closed circles on the end, so just make sure you know that. Okay, if you're done, or once you're done, check your answers. And if any questions come up, let me know. Raise your hand if you have a question as to why something is what I have versus what you thought it was. Very good. Yep. So what he's noticing is that the relative max and the absolute max are the same thing here, and sometimes they can be the same thing. The relative max is any turnaround point that's a maximum, so that one, and it also happens to be the absolute highest point the graph ever reaches. Whereas your relative min and relative min and absolute min are two different points, because this is the relative min, but it is not the absolute lowest point. This one is. Good clarification. That's a nice thing to point out. Anything else? Okay, yeah. The domain is always going to be the lowest x-coordinate that's ever reached. So the lowest x-coordinate that's ever reached is -5 to the highest x-coordinate that's ever reached 5. Does that make sense? Anything else? Okay, let's flip over to the back. The only thing I want to talk about really quickly, you can do this multiple choice on your own time, is this limited domain scenario. Domain are all the x values that would produce an output. What x value would not produce an output here because it would make a denominator of 0? 4. So x cannot equal 4 for that one. So your domain would be all real numbers from -infinity to infinity, except for 4. Okay? How do you notate that in interval notation? The domain would be -infinity to 4, with a parenthesis around the 4, because we don't want to include it, union with 4 to infinity, with another parenthesis around the 4. That essentially includes everything except for 4, because you can't divide by 0. What type of numbers can't you take the square root of? Because you'll get an error on your calculator. Imaginary, or negative numbers, right? You can't take the square root of negatives. So this x plus 4 has to be greater than or equal to 0. Can't be negative. So when you solve that, you're going to get that x has to be greater than or equal to -4. Yes? Okay? And that's your domain. In interval notation, if you're greater than or equal to -4, that's your interval notation. From -4 with a bracket to infinity. Does that make sense? And Aiden, I want to talk to you quickly before you leave.